And a very good afternoon on behalf of everybody associated with the NADP program office and the Central Analytical Laboratory. Welcome to our continuing series of NADP training webinars today entitled Would Good Samples Go Bad? My name is Jeffrey Pribble. I'm joined today by Dr. Chris Lehman, the director of the Central Analytical Laboratory, as well as my engineer, Brian Kirschner, assistant data manager. Today we want to talk about doing samples from the moment that you put your bucket on the collector to the time that it actually gets analyzed, and we'll look at all those variables. If this is the first chance that you've had to join us for our webinars, we welcome you. You can look at archive webinars at the website that you see on your screen, goillinois.edu/NADP training. At any time, this is really kind of a laid-back type of atmosphere. So at any time during the materials that we'll be giving you today, you have a question, type it in, and the engineer, Brian Kirschner, will read it. We'll read it to everybody, and we'll get you the best answer available that we can give you, and sometimes get into a discussion, which can lead to other questions. So without further ado, we'd like to begin today and welcome you once again. Next slide, please, Brian. You can see on the front a little cartoon variable there to a little jocularity, as Father Mulcahy used to say on MASH. What do you mean my sample's gone bad? How did that happen? When you put the bucket on, there's so many, like I said, there's so many variables that can occur when you do put the bucket on. Contaminations, equipment failures, those kind of things. So we can proceed to the next slide, please. Two different kinds of collectors currently in the NADP NTN network. The one on the lower right hand is our AeroChem collector. The one on the left is the one bucket collector called the NCON. Same protocol goes basically for both. You want to follow the protocol for opening and closing the collector, inspecting the bucket, putting the lid on, and doing everything you can to seal that particular sample before moving on to your next step, which is, transportation, decanting, and such. One important aspect in sample collection is to always make sure that whether you're working with either one of these particular collectors, that you visually inspect the sample before putting that lid on. What is currently there when you first open that lid, after transportation, swishing, whatever may occur from moving your sample from point A to point B, can get diluted and not necessarily there. So we like for folks to make remarks as to what you initially see when the collector opens up. Next slide, please. We take the sample back to the laboratory, weigh it. We're getting ready to decant it. This is just little reminders. We've been through this as part of our sample processing, but these are all areas that can cause contamination, affect the validity of a sample in one way or another, whether it be handling contamination, field contamination, or what we do in the laboratory. So basically what I'm doing here is pulling the lid towards me to keep my arm away from going over the top of the bucket. Next slide, please. Decanting the sample, what we try to do, and we'll elaborate on that a little bit more, is whatever you visually see in the sample, try your best to pour away from it. If you've got a big old leaf in there, do your best to pour away from that sample. But there again, once you've opened the lid to this bucket and opened the lid to the sample bottle that you will be sending off to the Central Analytical Laboratory, the time that you have both of these orifices open, then you need to be as cautious as possible in decanting the sample and putting the lid back on. Next slide, please. Okay, I've got the gloves on. I poured my sample. I've got the lid back on. Now that sample's capped, and make sure that it's nice and tight. And this particular sample is in the process of being on its way to the Central Analytical Laboratory. Next photo, please. Completed field form. We always stress that you complete every facet of this field form. Areas that we really stress are section 4 and section 5. We want you to see the operation of the particular collector and gauge that, the working aspect of the equipment can affect the validity of the sample. We will talk about that as we progress. Section 5, very, very important, the sample condition. When you initially look into that bucket, did you see any of these 6 particular items listed in Section 5? If you have, if you see it and you get back to the laboratory and you pop that lid and you don't see it, it's still important that you make note of it, because when we do the chemistry, those are the things that we look at as far as the way this works. Next slide, please. Field Observer Report Form, we highlighted sample condition. Once again, the types of contamination that you see. If there's any questions in regards to specifics as to what we mean by Section 5, then don't hesitate to ask. We're getting the sample all ready to go. We've got our field form completely filled out. Keep the pink copy for yourself. Make sure that the lid's on tight to the sample. You've got the bag marked. We're getting NTN sites. You can see that the way it comes in is processed. When it comes in the door, it is entered and the process begins the minute it comes in the door. The sample preparation is this is a part of the webinar that I'd like to turn over and introduce Dr. Chris Lehman, Director of the Central Analytical Laboratory, to give a little bit more insight about the chemistry process and what can make or break the validity of the sample. So welcome, Chris.
Well, thanks, Jeffrey. I hope my mic's on here. Jeffrey deals a lot with the site operations, and that's why he emphasized that in his talk. And we really do value all the observations you make on the field form, because all of that is entered into our database and goes into the sample screening we do here. And we always say you're the first line of observation. So please, if you see anything amiss, anything to do with sample observations, observe that on your form. Once the sample enters the Central Analytical Laboratory, we make additional observations of the sample condition. We look at contamination, and that's to ensure uniformity across the site. So maybe you missed some contamination, but what we're looking at here is our apparatus for filtering the samples. So we do make observation as we're filtering the sample to see if there's contamination that may have been missed on the observer form. And we'll be coming up to one of the preliminary data reports in a minute. You'll be seeing where we note contamination that was noted in the lab that was missed on the observer form. Go ahead, Brian, please. And so one of the first steps we do with filtration is to actually look in the 1 liter bottle that you submit as received, and that's right before we conduct the pH and conductivity analysis. That is the first chemical analysis done here in the laboratory, and that's the station you're looking at right now. We have our apparatus and instruments for doing pH and conductivity. And next slide. And then once we filter the sample and do pH conductivity, we prepare it for analysis in the laboratory. This is happens to be our flow injection system where we do ammonium and orthophosphate. And yes, I realize this presentation is about sample validity. Why are we in the lab? Well, it's really the chemistry that we look at for screening when we have contamination in the samples. Just because you observe insects or leaves or plant matter or even bird droppings in the sample, it doesn't guarantee or indicate that the sample will be invalid. It's only when we look at the chemistry and the history of the chemistry at the site that we decide whether a sample is abnormally contaminated. Next slide, please, Brian. You should all be familiar with this. It's an NTN sample receipt report. You receive it here from the laboratory. This is what you receive on a monthly basis. The top part is basically the information that is off the field form with a few additional pieces of information. We have what's on the right-hand column, the information from the block 5. That's the sample condition. And here we indicate the fields that are on the field form and listing the visible contamination in the sample that was observed at the time of sample submission. So in this sample, for example, we see there's no bird droppings. The sample wasn't cloudy or discolored. There was soda ash or dessert particles observed and no other contamination. And just draw your attention to the last one there. There's a note about contamination observed at Cal. That's an observation that's made at the point when we're looking at the 1 liter bottle prepared for analysis and also through filtration. We will make observation about any contamination in the laboratory. And then just a note across the bottom of the form, once you receive your monthly report, we will have chemistry run, so we indicate the chemistry values there across the bottom of the form and any problems with the sample. Another report you receive is a summary report, and just want to draw your attention to 2 blocks there. The first one being in the upper right-hand corner, which lists validation notes codes, and I believe that's on the next slide or there. We'll go to there in a minute. That just lists the notes flags that we have, and then what we anticipate being the quality rating code. And I just want to talk about that a bit. This is relatively new to the National Trends Network. I think we've been doing it just about a year now, where formerly we talked about whether a sample is valid or invalid, and now we actually assign an A, B, or C rating, where A data indicates samples that are the most clean, if you will, the most valid. B samples indicate those sampling periods where there might have been some minor issues, and C indicates where there were major issues for the sample and the data are actually considered invalid. In the lower right-hand corner on your monthly report is something you want to be mindful of. Each month we have a running tally of the samples year to date of the number of A-rated, B-rated, and C-rated samples. So we'll be talking about completeness criteria later in this presentation, or in other words, the amount of valid data you need at your site to be considered to be representative of a year. But this is just some running numbers that show the number of valid samples. Next slide, please. Here, this is perhaps the most tedious part of this presentation, but I'd like to briefly go through each of the NTN notes and quality rating flags. You will receive this in your monthly report. It's one of the attachments you receive. You receive your data reports plus a cover memo that you hopefully open and read. It has helpful information, reminders, and it also includes a listing of the notes and quality rating flags along with our current analytical detection limits. And just briefly, these are in alphabetical order. I want to describe them and talk about what they mean and things you should be watching for if you're seeing these flags. First of all, the A code, the incomplete laboratory analysis, that can happen for a number of reasons. Most often this is for low volume samples where we would have only had enough sample to do a pH analysis and we don't have a full chemistry for this sample. And that gets, we've talked about this, the quality rating code, or what we use the term QR. We call that B data, so it's not a full and complete data set. B is a bulk sample. That means your collector was open entirely for the period, not just when it was raining. So it collected both wet and dry deposition. That the chemistry are reported, but are considered valid, or sorry, I should say invalid for the purposes of the NADP, and thus receive a quality rating code of C. Notes code C indicates grossly contaminated samples. That's where we observe sample contamination, but the chemistry, once we screen it against the history of the site, it's very anomalous. And just briefly, basically, it's in the top 10th percentile of high levels for a number of analytes. And if you have questions about that, we have a very rigorous algorithm. We can provide you more of the information about how we do that. The D code indicates visible debris in the sample. So all samples with visible debris will have a D code and will have at a maximum a quality rating code of B. Those where the chemistry is also thrown off might receive the C code or be indicated as being grossly contaminated. So D and C really kind of go together there. E is something we see a lot, especially with holiday periods. To be considered valid, the NTN samples have to be no more than 8 days and 2 hours long. That's 194 hours. In other words, if you collect a sample on a Tuesday morning at 9 a.m., you have until the following Wednesday at 11 a.m. to collect the following sample for the period to be considered valid. So we set a maximum sampling period of 194 hours for a period to be considered valid. So if it's a 2-week sample or a 3-week sample, it's considered invalid. F, major field protocol issue, indicates a major issue at the site. It could be we've had bears steal buckets, we've had vandalism, we've had samples accidentally discarded, they've been lost in shipping. Basically any issue that happens before the sample receives the laboratory. The Sample, if we have it, we always analyze a sample because once we dump a sample, we can't go back. But if at all possible, we analyze the sample. There are chemistry data, but they're flagged as being invalid. H indicates a sample handling issue, and this can be for a number of things. I believe we can assign it manually, but it could be any number of things where we view that the data aren't considered A quality and they're downgraded to a B. The I indicates low volume sample, so this is where we had enough sample to do a pH analysis, and then we add additional purified water to it to bring it to a volume where we can do a full analysis of through all of our instruments here at the laboratory. That's not an ideal condition. While we do have a complete chemistry, there is some uncertainty there, so we downgrade the quality to B. It is considered valid data there. L, laboratory error. This does happen on occasion. We've spilled samples on rare occasion, or some handling issue in the laboratory. In rare occasion, samples will be flagged with an L error indicating lab data. M indicates missing data. Maybe you forgot to weigh the bucket. Maybe you forgot to make some observation on the field form. In general, this should be a pretty rare observation, but we do flag it for your information. N indicates no sample deployed. Basically, it's a gap in the record. P indicates that the precipitation value is unknown. That means either the primary rain gauge data are missing, and the sample volume is missing for some reason, that the bucket couldn't be weighed, but we really had no indication or measure of the precipitation value at the site. We might have valid chemistry, but we give it a quality rating of C because we really need the precipitation value to do the weighted average for the year. U is an undefined sample. It goes with the bulk sample above. So bulk indicates that the bucket was open for the entire sampling period. U indicates that it was simply more than roughly 6 hours for the week, collecting excess dry deposition. V is an inadequate sample volume for full analysis. This happens for very light precip events where we should have had enough sample collected, but we didn't, and that gets invalidated. And then finally, as we go through our list, Z, site operations issue. This comes if you flag one of the site conditions on the field form, such as your collector or motor box didn't operate properly, or perhaps your gauge didn't operate properly. The chemistry are valid, but we do flag that there's an issue. I'm sure all of you got that, and if you have any follow-up questions, be happy to email us. I know it's long and tedious.
How about I jump in real quick? A couple comments I want to make real quick if I can. On the handling contamination, if you have in the field something where you accidentally touch the lid or the bucket or something along those lines, make sure that you make a note. I had an operator in a training course a long time ago say, well, I just turn it the other direction, hope that you won't catch it. We scrutinize our data. It is quite detailed. So, I mean, if you have something that could cause possible handling contamination, make a note of it in section 10 of the field form and let us know what occurred. That doesn't necessarily, by having handling contamination, like Chris said, doesn't necessarily invalidate a sample. Also, the no sample deployed. With all the samples we got going back and forth in this massive transit world, sometimes we lose samples, not us personally, but our delivery systems. That's where it's really important to keep a copy of your pink sheet, your pink part of your field form. That way, if something does get lost in transit, then we can refer back to you. You fax us the information, and we get the data from you. We can still process the data and code the sample as a loss.
Reason samples can be invalidated. Jeffrey highlighted this a bit. We had some comments about the sound. Sorry, please let us know if there's any issues in the broadcast. From our end, we're live and everything seems fine. So let us know if you're having issues. Jeffrey highlighted some of these. Obviously, please don't hide anything from us. If you feel that you've made an error, note it. We want to make sure ultimately that the chemistry from your site represents the environment. So I know you feel like you're getting a grade if you have an invalid sample, but we don't see it that way. We're here to help you. We're here to represent what's falling out of the atmosphere. So the first of all, if there's any leakage into the bag, once something leaves the bucket, it doesn't go back. It's a one-way trip. So if something leaks out of the bucket, don't ever attempt to pour it back. And again, please. Also, we had this recently here. The dry side bucket, for those of you with the older Aerochem style collector, any sample in the dry side bucket isn't the wet deposition measurement we're looking for. Don't ever pour that water into the good sample. Unless it's extraordinary reasons, you shouldn't be decanting that and pouring it for us. Grossly contaminated samples, we talked about that a bit. We've had bats in samples, we have snakes, we've had toads. We honestly look at the chemistry before we decide whether or not something's invalid, unless it's just completely corrupted due to vandalism. We highlighted number 4. I want to emphasize this with the upcoming holidays. We do hold 8 days, 2 hours for a valid sampling period. Number 5, bulk samples. We may, on occasion, if there is no power to the collector, instruct you to collect a bulk sample. There are researchers that do use the data. Although it's considered invalid, it is beneficial to have these samples in the record set, and we do have the rainwater for other analyses. Number 6, we also highlighted excess dry deposition. This is often due to equipment issues, say power outages during storms or sensor failure, but undefined samples are considered valid, although we do actually measure the chemistry and report it. Number 7 happens reasonably often, especially now that we're in the colder weather. We do require you, when you have frozen precipitation, to thaw it completely. And the reason for that, and you might say, well, gosh, why? I mean, there's liquid there. Well, it thaws unevenly, and you'll see this, if you've got your drink or something. The cleanest water usually stays frozen, and then it's the dirty water that tends to thaw, those that has the salt in it and the bit. So really, you don't, it's not considered complete. The only exception I say to that is if you can fit the entire sample, if there's just a few chunks of ice and you can pour it all in your 1 liter bottle, that's fine. But we always advise best to let it thaw completely, and certainly don't just, don't be in a hurry. Don't just let it thaw enough to pour out into the bottle. If you have to, we advise let it sit out at room temperature, or ideally in a cool place above freezing, and let it there. You want to make a note on that, Jeffrey?
Yeah, one of the rules that we have is that you try to get it sent off to us within a 48-hour period. I got a question from an operator yesterday as to, am I unmuted? Okay. My apologies once again. On number 7, 48 hours after the sample comes off, we ask that you have it within transit, in process within the 48 hours. So, letting it thaw at room temperature for a day or so will allow you to do it. If, like Chris said, if you're pressed for time or something like that, then do the best you can. Also on number 4, if we could go back to number 4, a lot of the operators will ask, okay, specifically a couple of years ago when Christmas occurred on a Tuesday, what we want you to get is a sample that's under 194 hours. So if you have to go to a Monday to Monday or a Wednesday to Wednesday, as long as you can get back on that Tuesday to Tuesday cycle at some point, then it's okay to go ahead and change your sample on a different day, as long as it's convenient for you and under the 194 hours.
Okay, going on to number 8, reusing unclean buckets. If you're short of buckets, we put notes in them, the next to last, about you're coming up on your last bucket. Don't ever reuse an unclean bucket, one that was on there for the previous week. We can get you supplies pretty quick. If you let you know, we've overnighted some supplies, so please let us know. Don't attempt to reuse unclean buckets. And then number 9, field handling error. We talked about that. So there's vandalism, there's bears out there. We've had things lost in shipping. Okay, next slide, please. Do's and don'ts, and please feel free to chime in here, Jeffrey. Jeffrey already highlighted number 1. We've had samples lost in shipping, and we're trying to rebuild the record. We ask you to keep that pink copy for your records, ideally for at least a year. It happens maybe once a week. We'll ask a site to fax us the copy in, especially with the upcoming holidays. Tracking information isn't 100% reliable. You may see that it's received at the lab, but we get 300 samples at once. We sign for one thing. We don't check them one by one. Samples float around with UPS for a while, especially around the holidays.
And the field form is a reference point for going back and talking to an operator about, maybe the difference. A lot of the stress is to get within the 5% between the collector and the gauge. And a lot of times when you're not within the 5%, there can be the question as to why not. We can elaborate a little bit further into the function of the equipment, what may have occurred. So keeping a field form handy to where we can use it as a reference point is very important.
Yep. Number 2, Jeffrey showed a picture early on. We have the bottle bag. That's to contain leakage from the bottle. Please don't put your field form in there. It won't keep your field form dry. In fact, it'll get wet from potential leakage from the bottle. So keep that separate there. Number 3 is also important in winter. When water freezes, it tends to expand. So we do recommend leaving about an inch at the top of a 1-liter bottle to allow a bit of an expansion to keep the bottle from cracking if it freezes. Number 4 is important. This is good decanting practice that Jeffrey highlighted at the beginning. Any debris in there, let it settle. Don't attempt to swish it around and get it all there. We really want the leaves and vegetation and the grass to settle out. We just want to decant it, leaving the debris there, and that goes along with number 5. Number 6 is a big no-no. Don't ever reach into the bucket to remove the debris, no matter how disgusting. We've had all sorts of odd stuff in our buckets. Don't ever reach in there because you're certainly going to contaminate it or break it up. And then number 7, we've said this, no matter how trivial you think it is, we do read all of your comments. Jeffrey and Brian read each of them. They get keyed in by someone. For permanent posterity in the database, always make notes in the remarks section of the field form, because when in doubt, we depend on these comments. We might go back to you with questions. You might think you remember something, but would help to have the comments to help refresh your memory. And then number 8, always call us if you have any questions, needs, or comments. There's also email, ntn@isws.illinois.edu. We should have included that is on your field form. Okay, next slide. Anything to add to that, Jeffrey?
I just want to stop for a moment and ask if anybody has any questions that they would like to ask. Anything there, Brian? Okay, if there's no comments about, or questions, next slide is what can be done to reduce the number of invalid samples. Always practice the NTN procedures. We have a protocol that we stand by. Was written, scripted, practiced, and we've gotten the best results over our protocol over the years to avoid the invalidity of samples and keep the operator safe and sound. Always have try to have a backup operator. If you're going away for a period of time, we see this a lot at the universities and stuff like that within the network. Always try to train somebody in the same light that you've been trained yourself. That way everything can be done as if you're away. People say, well, I want to, might as well do it myself. But you got to train somebody as a backup in case you're unable to collect a sample. If there's a question about what the particular protocols are for your backup, I can send you the information, but try to assure them of everything that's necessary for collecting a valid sample. Ensure the power supply is adequate, whether you have AC or solar. As you get out of, we normally recommend twice a year when we winterize and summarize the gauges that you do a check of your power supply. Going into winter, you want to check your batteries, make sure that they're adequate. And understanding the function of these collectors, when you put together a battery bank and run those in parallel, you have, say, a 4-battery or 2-battery set that you're running in parallel. The function of this equipment is that the collectors and the equipment will only work as well as your worst battery. So a recommendation a couple times a year is to take the batteries and have them load tested to make sure you're just checking them for, whether they're going to stand up for another harsh winter or what the occasion may be. Perform weekly equipment test. What you want to do is whether you're working with the grid sensor for the aerochems or the optical sensor, the thief sensor for the NCON, trigger your collector. Make sure that it's going to open and close like it should. Is there any residual bird droppings on the sensors? Clean those off. Make sure that it opens and closes in a timely fashion. And if there's any more questions about that and you need me to elaborate a little bit more, I can. Keep vegetation trimmed around the collector. You don't want to get too high, but then again, you don't want to mow it down to the very nub of the grass. When you get the high winds that we get here in central Illinois, when you mow it down to the dirt and the wind kicks that up, that can stir it up and cause a contamination, especially with the thief sensors, the optical sensors. What we're seeing now is the collector is getting activated by the debris going between the optical sensor beams on the sensor itself and causing the collector opening and closing. So you want to minimize the amount of vegetation around your collector that can trigger that sensor.
We got a question here, and it's an excellent question about bottle leakage. This is, as director of the lab, this is something that plagues us, and we talk about once a month. We do have a high frequency of leakage from our one liter NTN bottles. We know about this. That is one thing I didn't mention, so I'm glad it gets brought up. Those samples get checked when they get logged in, and we allow a little bit of leakage. I think it's up to 5 mils. We actually look at what's in the bag, and that happens. You'll have a little bit of condensate in there or something. But if it's more than about 5 to 10 mils, we do screen the chemistry because we've done tests that show that water can leak out of the bag, or rather, sorry, out of the bottle into the bag, and can also leak back. We've tested that. How to prevent leakage? The question was specifically, is bottle leakage getting less frequent across all sites? And yes, in general. We've tried about everything. You'll see the note on the field form, try to tighten the bottle and that. We found sometimes they can be over tightened and that could cause an issue. We are putting new bottles into the system. Some of you probably noticed them by now. They have a green dot on them, and that's to mate up the proper lid with the bottle. It's a new generation of bottle. They're also slightly more flexible. We call them squishy bottles. And those do seem to be helping. We're phasing them into the network as fast as we can and phasing out the old bottles. But in general, yes, the amount of leakage is not increasing and appears to be trending down. So if you have concerns, feel free to call us.
One comment too is in your tightening of the bottle, we've had operators in the past that try to put tape around. We try to put tape around the cap of the bottle. These bottles are cleaned and reused, so any sort of residual that you may get from wrapping tape around that can introduce itself as a future contaminant in the bottle itself. So please don't use any tape in trying to tape the bottle shut.
Yeah, we found the tape. That was one of the things we tried. We tried tapes and bands. Another great question about bottles. What should we do with bottles that appear to have condensation in them when they arrive to us? We don't dry anything. You'll probably notice your buckets and your bottles arrive slightly wet, maybe a few drops of water. That's important. As soon as we try to dry things or flow air, we contaminate them. So what we ask you to do with both your bottles and buckets, just simply upend them and shake them out. Any water there is not meant to be there. I mean, we shake them out as best we can when we're packaging the materials, but it's always good practice to upend the bucket before you put in the collector to, hold the rim with the bag so you're not grabbing the rim, but dump any rinse water out of there, of the bottle or the bucket, before you attempt to decant the sample. So good catches. Appreciate those questions. Completeness criteria, the second most tedious slide in this presentation. We're not going to spend as much time as we did on this with the sample flags, but basically, and this is the time of year when we are mailing out the summaries from 2013. We've prepared the maps, and you may come to it and say, well, hey, where's my site? Well, NADP runs by a scientific committee, and they've established 3 criteria for evaluating the validity of a site. And basically, we require a minimum amount of data under these 3 points. The first of it is we need to represent the total sampling time for the year, and we require 75% of the year be represented by valid samples. In other words, in a 52-week year, we need 39 whole weeks of valid data to be considered acceptable to the network and to be included in our annual summary. So that's criterion 1, as we call it. Number 2 is we need to represent the total amount of precipitation that fell at the site. And for that, we have a slightly more stringent criteria. We require at least 90% of the year to have valid precip measurements. Now, that doesn't mean, you could have rain gauge issues. You may know, and this is getting into the details of it, but if your rain gauge fails, the NADP substitutes the depth of precipitation collected in the wet deposition bucket. So basically, the total amount of missing records of precipitation record, be it from your gauge or the collector bucket, can be just 10% of the year. So for 52-week year, you can have about a little bit more than a month of missing precipitation data. The last one, criterion 3, it's similar to the first one. We're looking at the time, but we're looking at the total volume or the total precip depth of the year that's represented by valid samples. In other words, we need 75% of the precip that fell at your site to be represented by valid samples. So if you have, on average, about 40 inches of precipitation at your site for the year, we need valid samples representing at least 30 inches of that. So that's the criteria there. There's more details on the NADP website, or as always, call us with questions. But you can see these completeness criterion if you download your data online off the website. And then this is just an example. We're preparing the mailing now. This is on the website. This is just one example of the nitrate ion concentration for the United States from 2013. And this is the map product that shows all those sites that met the completeness criteria that I talked about in the previous slide.
This is a part of the website, or this is what you can look at as far as your precip data. When you send in your precip data, whether it be with the NOAA 4 gauge or the OpPluvio gauge, you can get on this. As soon as you submit this, within about a 10 or 15-minute period, this will appear on our website, or this particular website, to where you can go in and highlight your site, the start and stop data when you downloaded, and look at your visible data. Next slide, Brian. What we really want to do is call our attention to the far right column, which is a completeness criteria, as Chris was talking about, for the amount of download of the sample. You see 100%, but then again, you may see the one column there about halfway down, or 5 weeks down, that goes from 1024, that only has 39.58% of the completeness criteria. That's the part in the precipitation that can be caused by, say, power issues, collector issues, rain gauge issues, whether it be download issues with your PDA or your flash drive or your load cells, data loggers, whatever it can be. So that's what we look at as far as the completeness criteria in that far right column. Also, and I don't want to elaborate on this too much, but if you've never looked at this particular slide when looking or reviewing your data, this basically gives you a function as to what your collector and what your gauge did throughout the week. It tells you the number of cycles and amount of wet exposure, the amount of dry exposure, and the amount of mist exposure. This is all criteria data that Brian and I look at as far as distinguishing whether the collector and the gauge are working properly. So if you would like me to elaborate a little bit further on that, feel free to give me a call at that 1-800-952-7353 number.
Yeah, and the reason we emphasize this point is it may look like you've got a precipitation measurement, but really the data that are less than 100% are considered invalid for the period, because we're just missing part of that record, and we're trying to get the most accurate precipitation value or total reading for your site as possible. I think that's our last slide. We'll take more questions. I see a helpful tip there. Operator passed on. It helps to do a final tightening. We talked about the 1 liter bottles. It helps to tighten the lid without any gloves on, and that's perfectly fine. We'd like you to wear gloves while you're decanting, but once the lid's on, you can certainly handle it with your hands. That's fine.
Can we go back to the slide? I want to point out something real quick on that precip data, Brian, please. On the bottom right-hand part, when you look at this after a complete week of downloading, where it says 1027, if you look over on the far where it says data completeness and you see less than 100% and you say, well, I submitted my data, don't be alarmed, because when you took your sample and downloaded your data, you were doing it at, say, 9 o'clock in the morning, so you're not getting the complete day. So don't be alarmed if you only see a particular percentage, because after you download the following weeks and you go back and reference that, you'll see that it moved from a partial percentage to the 100%.
Good point. Just the final slide has our contact information there. Email, fax, phone, we'll take anything.
If anybody has, like I said, if anybody is just joining us for the first time, you can archive past webinars at the goillinois.edu/NADP training. If there's ever any questions or comments, give us a call at the 1-800-952-7353 or our email. And we appreciate you joining us. We do this about every couple months, a different subject matter. If there's something in particular you would like us to cover, when you get the monthly memos and monthly mailings, that you open them up, some of the information that we try to pass on to you come in those memos. When you get big boxes from us full of new supplies, always open that box. We send supplies in those boxes as well. Any final comments or questions?
Just want to say appreciate Jeffrey's time and Brian's time this year. This is our last webinar for 2014. We're looking for ideas for next year, so if you have any suggestions of webinars, pass that on to us. We do this to help you, so if there's information you feel lacking in our documentation, we'd be happy to do a webinar on it, and appreciate your taking the time this afternoon to join us. We couldn't do our job without you, so thank you.
On behalf of everybody associated with NADP and the Central Analytical Laboratory, for my engineer Brian Kirshner, for Dr. Chris Lehman, the director of the Central Analytical Laboratory, I'm Jeffrey Pribble, saying happy holidays to you and yours, and look forward to seeing you and hearing from you in 2015.